Hello. So I'm going to do 3 derivatives using the definition of derivative and a whole bunch of algebra. So let's get going. Let's find the derivative of f of x, which is x squared plus 3x plus 4. And what I recommend you do first is identify f of x plus h. So just plug in x plus h into the function and figure out what that is first, because we're going to need that for the definition. I suppose I should remind you what the definition of derivative is. Let's write that over here on the side. The definition of derivative is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x, ooh, I squeezed it right in there, over h. Right? It's the limit as h goes to 0 of the difference quotient. So we're going to try and construct that thing and then do the limit. And to construct it, the first thing we need to do is square x plus h. Right? We're plugging it into the function, so we're going to square it. That's an h right there. And then we'll do plus 3 times x plus h. I was going to make that blue. Let's, if you're going to use a color, I might as well do it right. So 3 times x plus h. Right, I'm putting this green x plus h wherever x is in the function, plus 4. And then I recommend that you simplify this thing by expanding it and combining any like terms if we have them. So this is going to be, oh goodness, x squared plus 2xh plus h squared plus 3x plus 3h plus 4. And I do not have any like terms there. So that is my f of x plus h. So just to be clear, we know f of x because it was given, and we figured out what f of x plus h was. We just plugged in x plus h, and then we expanded the binomial, and we distributed to 3. Okay, that means that our limit, f prime of x, remember, the limit is called f prime of x. F prime of x is going to be, I said limit, I mean the derivative. The derivative is f prime of x. It's going to be the limit as h approaches 0 of this guy minus this guy. So x squared plus 2xh plus h squared plus 3x plus 3h plus 4 minus, and I'm going to put it as a quantity in parentheses because we have to distribute the negative sign, x squared plus 3x plus 4, all over h. So this right here, this is f of x plus h, and this is f of x. So f of x plus h minus f of x over h. All right, now, the last thing I'm going to write on this slide before we go to the next slide is I'm just going to clean this up a little bit because there's a bunch of canceling that we can do. When I distribute this negative sign, that makes this negative x squared, that makes this negative 3x, that makes this negative 4. So that's going to cross out x squared, 3x, and 4. All right, so simplifying our work here, the new limit as h approaches 0 is 2xh plus h squared plus 3h. And then remember, all these guys canceled out, right? This canceled, that canceled, and that canceled. So that's all I have left on in the numerator. And then on the bottom I have an h. And what we'll notice on the next slide is that there's a common factor of h in each of these terms in the numerator. So I'm going to factor that out, cancel the h, and then compute the limit. But I'll do that on the next slide so I can clean it up a little bit. So I just copied it over from the last slide. We were computing f prime of x, and we had it down to this limit. Notice that there's a common h factor in each of these. So I'm going to factor out h, and that will leave me with 2x plus h plus 3. And we're still over h here, right? And we're still doing this limit. We have not sent h to 0 yet, so we got to keep that notation there. At this point, this is great news. We've just eliminated that division by 0. So now I just have the limit as h approaches 0 of 2x plus h plus 3. I'm going to perform substitution, so I'm going to take that 0 and stick it where h is. And I end up with my derivative function being 2x plus 3. This is the derivative of f of x. This is f prime of x. This is a formula for computing the slope at a particular point on this curve. I like to call this a slope machine, except I spelled it wrong. Derivatives are slope machines. So we just made the slope machine. The formula for the slope is 2x plus 3 at any given point on that parabola that we just had. Okay, I want to keep the video going, so let's try another example. I said we had 3, I got to give you 3. That was the first one. So here we have f of x is the square root of x plus 4. We've got to deal with this radical. Remember, our first step is to go ahead and figure out what f of x plus h looks like. It just makes it easier to set this thing up if you do that calculation ahead of time. For us, that's pretty simple here. This is just going to be x plus h plus 4, right? So I put the x plus h in, and then plus 4. I didn't even bother including the parentheses because everything's added there. So now I have f of x plus h, and I have f of x. I can write out my derivative using the definition. F prime of x, the derivative of f, is f of x plus h, which is x plus h plus 4, that's an h there, minus f of x, which is square root of x plus 4, over h. Oh, I forgot the limit, didn't I? Doggone it, you can't forget that. Just pretend that never happened. F prime of x is the limit as h approaches 0. You don't get the derivative until you take the limit of that difference quotient. Okay, so now we have this limit, and we've worked with limits like this before. We have this difference of two square roots. We like to multiply by the conjugate to evaluate these. So I'm going to multiply by square root of x plus h plus 4 plus square root of x plus 4 over the same thing, square root of x plus h plus 4 plus the square root of x plus x plus 4, sorry. Okay, so we multiply, let me just clean that up here. We multiply by that conjugate. And the point here is we want to eliminate these square roots, right? When we multiply these two things together, that's a difference of perfect squares, and we'll eliminate the radicals. In the bottom, all I'm going to do is write them the h next to the quantity. All right, so I'm going to clean this up a little bit before I go to the next slide. Here's our derivative. It's going to be the limit as h approaches 0. When we do the difference of squares, we get x plus h plus 4, the square of the square root of that, minus x plus 4 over h times the square root of x plus h plus 4 plus the square root of x plus 4. Don't bother multiplying that one out because the h is going to cancel. That's our whole goal, is to get rid of that h. Okay, so watch what happens in our algebra here. I'm going to distribute the negative signs, so that makes this a negative x and a negative 4. That means the x and the 4 are gone, and all I have left on top is h. So on the new slide, I'll have h in the numerator, and then I'll have h times the quantity down below in the denominator, and we'll cancel the h's. And then we'll wrap this one up. Let's get that new slide, though. So I rewrote our expression that we were working on. In the numerator, we canceled everything except the h, and I haven't touched the denominator yet. What's going to happen is these h's cancel, and this becomes a 1, right? At this point, I can try substitution again. I'm just going to stick a 0 in where that h is, and what I end up with is something awesome. I've computed the limit, so I don't need the notation anymore. I have 1 over the square root of x plus 4 plus the square root of x plus 4. And just recognizing that when there are two of those on the bottom, we can simplify that to 1 over 2 square root of x plus 4, right? Square root of x plus 4 plus the square root of x plus 4 is 2 square root of x plus 4. So this is our derivative function, right? This is our slope machine. Yay. We did it. Just use our conjugate, right, multiplying by a form of 1 to get that one done. That was example 2. Let's go ahead and do example 3. So for example 3, our function is f of x equals 2 over 2x plus 1. We've got a rational function here. We're not going to panic. We're going to follow the same process. We're going to start by plugging in x plus h into f. And when we do that, I'm going to put it in as a quantity because I have to distribute the 2. And when I clean that up, I get 2 over 2x plus 2h minus 1. Please don't try and cancel those 2's. There's no common factor on the bottom. You can't do that. Okay, so this is f of x plus h. This is f of x. Now I'm going to put them in the definition. The definition of derivative is f prime of x equals, and don't forget the limit part, the limit as h approaches 0 of f of x plus h, which is 2 over 2x plus 2h minus 1, minus f of x, which is 2 over 2x minus 1, and the whole thing is over h. Now, what I recommend that you do so that you don't go crazy is that you just rewrite this a little bit. Let's get rid of this bottom fraction, and let's write it as this quantity times 1 over h. And then our strategy is going to be simply to first subtract these two fractions. We're going to subtract. To do that, we have to have a common denominator. And then when we get done, we'll multiply by 1 over h. Okay, so let me show you how we get that common denominator, right? The first fraction needs to be multiplied by 2x minus 1, so that's going to look like this. The numerator on that part will be 2 times 2x minus 1. Then I've got my minus sign, so I'm going to bring that minus sign right down. And then this 2 needs to be multiplied by the other denominator, 2x plus 2h minus 1. And that's all over the common denominator of 2x plus 2h minus 1 times 2x minus 1. Do not multiply that out. We're going to deal with it using substitution once we're done. And then remember, we're dividing by h, right, because we're sending h to 0, but I'm just telling you it's easier to write like this. Okay, now in terms of algebra, what's going to happen is I have to distribute this 2 and this negative 2. And I'm going to do that on the next slide. So I'll end up with 4x minus 2 minus 4x minus 4h plus 2 after I distribute. But I'll do it on the next slide because I'm running out of space. Okay, so I've rewritten our expression after this distributive property, right? I get 4x minus 2 minus 4x minus 4h plus 2. We're going to combine some like terms here and get some stuff to cancel. So the 4x's are gone, the 2's are gone, and in the numerator now all I have left is negative 4h. That is great news because I'm multiplying by 1 over h, so I can cross this. Oops, that's not what I wanted to do here. Let me I can cross out this h and this h. And all I'm left with in the numerator is negative 4. And at that point, I can do substitution. So let's just rewrite it so you can see what's left. We crossed out all the yellow stuff and the white stuff, and all I have left is a 4 on top, negative 4. And then on the bottom, I have 2x plus 2h minus 1 times 2x minus 1. Now we can do substitution and see what happens. Take the 0 and put it in there. That means this is 0. And so I have 4 over 2x minus 1, because the 0 goes away, times 2x minus 1. And a more concise way to write that, the normal way we write that, is 4 over 2x minus 1 squared. It's not 4, it's negative 4, sorry. You're probably yelling at me right now. Negative 4 over 2x minus 1 squared. That is our derivative function, f prime of x. We did it. So there you have it. 3 examples using the definition and a lot of algebra. You're going to get tired of this quickly. I understand that. But we do need to run through this process using the definition so we can get a handle on these calculations. But ultimately, this is not as practical as some shortcuts that we're going to learn soon in class. So stick with me. Good luck on these, and stay tuned for some shortcuts. Take care.